Hello and welcome back to another episode of Math with Sohn. Today, we're going to be doing some piecewise functions. And the first thing we're going to be doing is evaluating piecewise functions depending on the input values. So before we get into that, I wanted to tell you kind of what a piecewise function is. And if we look here as a graph, you can tell that we have one line, and then another line, and then a third line. So a piecewise function by definition is just multiple lines or parabolas or absolute value graphs or anything of the sorts pieced together into one continuous, potentially continuous thing. In this case, it is not continuous, it is disjointed. All right? So, for number one, we have to find f of negative 4. So typically that means you plug negative 4 in for x. So we could plug it in for the first one, the second one, or the third one. We're not going to plug it into the f of part. We need to determine which equation are we going to plug it into. Are we going to plug it into the top, middle, or bottom? And that's going to be based off of these restrictions on the domain. If it's negative 4, is it smaller than 3 or less than negative 3? Is it in between the negative 3 or the 0, or is it bigger than 0? Well, negative 4 is less than the negative 3, so that means that we should be plugging in the negative 4 into the top function. So this is going to be negative 4 plugged in plus 2, which means f of negative 4 equals negative 2. All right. Where does the negative 2 belong? Well, the negative 2 isn't smaller than negative 3. It's in between negative 3 and 0, so we're going to be plugging it into the middle function. So this is going to be 2 times negative 2, which makes negative 4. And then the last one, we got 0. Well, you may notice that 0 is in the middle equation. It's also in the bottom equation. So here in the middle equation, it just has less than, and 0 isn't less than 0. It's equal to 0, and that's what is apparently here, where we have x is greater than or equal to 0 for the bottom function. So that means that we would be plugging it into the bottom function because it can equal 0 here. So that would be negative 2 times 0 plus 1, which ends up being 1. Now, do not think that it's always going to go in order. It went in order this time because we're trying to make it easier, but these could have been for any of the top, middle, or bottom functions. They just happen to go in that order. So what do we do if it's graphically then? If it's graphically, you need to be looking at these x values here, and that would be the domain that you're worried about. And if you have 0 for x, so find 0 for x, it's right here. Where it does the line or the graphical part that is on this graph exist? Well, it exists right here. This is at the point 0, 1, 2, 3, 4. And that means that the y value is 4, and you're writing the y value down here. 0, 4. 4 is the answer. What about at negative 1? Well, at negative 1, we have negative 1, 4. But we also have this point right here, which is at negative 1, negative 2. Well, which one's it going to be? Well, if it's filled in, it is allowed to equal it. If it is hollow, it is not a part of that function. It is not a part of that answer, which means that the negative 2 is not going to be the answer. It's going to be on the filled in section, which is at here, again, at 4. We're going to find that 4 is a lot of answers this time. 3, if we go to 1, 2, 3, we are still at 4 right there, 3, 4. So it's still at 4. And last but certainly not least, 5, g of 5. We're going to go to the right by 1, 2, 3, 4, 5. Here we're at 5, and then we're going to go up till we hit a line, because if we go down, we don't hit a line. And that point is at 5, 5. So we're at 5. Okay? The next thing we're going to be doing is graphing piecewise functions. If we're graphing the piecewise function, then I would recommend, until you get good at them, writing with a pencil, not a pen. Even myself, I make mistakes on these, so I would recommend using a pencil. That way you can erase. In fact, that is one of my techniques, is to graph maybe the whole line and then erase the part that isn't needed. For example, if we wanted to graph 2x minus 4, that has a y-intercept of negative 4 and a slope of up by 2 and over by 1 and up by 2 and over by 1. If you graph that whole thing lightly, what part should be graphed? Well, we should only be graphing when x is greater than 0. So if we're graphing when x is greater than 0, I don't want any of the parts that are smaller than 0. So this part that I originally had lightly graphed shouldn't be there. Not only that, but you may notice it doesn't have the equal to symbol here on the 0. So that means that we should actually have a hollow circle where we started and then be doing the up by 2 and over by 1 for the slope. All right? What about the other part where it says f of x is equal to 3? Well, what does y equals 3 or f of x equals 3 look like? Well, that is a horizontal line. And here, if we're careful, we'll realize that it shouldn't be any value greater than 0. It should only be the values less than 0. Well, less than 0 is to the left. If you did both parts, like I'm kind of lightly doing right there, you would have to erase that, and it would not be considered a part of the answer. You only want the piece that is less than or equal to 0. So it's a solid circle, filled in, and it'd be going to the left. All right, is it continuous? Well, no, you see this big jump right here, so this is not continuous. Okay, next one. This one has 1, 2, 3 graphs. That doesn't really make it any harder. It just means that you got to graph an extra thing. So we got to graph g of x, which is the same thing as y equals, it's just a labeling mechanism, is equal to -2. So that would be a horizontal line, and I'm going to make sure that I stop when it reaches -1, and this has a bracket around the -1, so it will be a filled-in circle at -1, because when it is a bracket, it is allowed to equal it. Now the parentheses, you can't get to infinity, that's why it's parentheses there. Okay, y is equal to 2x, g of x is equal to 2x. That has a slope of up by 2 and over by 1, and down by 2 the other direction and over by 1. And let's see where we're graphing before I graph the entire line, because if I graph the entire line, I know I'm going to have to erase half of what I graph right here. So it's only going from -1 to 1, which happens to be where I'm at right now. I'm at -1 and 1, so that is going to be this line right here. Now it can not equal the +1. So that would be a hollow circle there. It can equal the -1, and nope, it can't equal the -1, but it was already a part of that. So that is filled in because it was already filled in for this one. It was hollow and then got filled in by that one. Now currently, this would be considered a continuous function. It had no breaks, no gaps, although we were not done yet. Let's see what -1/2 x plus 5 tells us. So -1/2 x plus 5 has a y-intercept of 1, 2, 3, 4, 5. And this one goes down by 1 and over by 2. And it includes the 1, which would be right here, and then goes forever. This had all the potential of being a smooth continuous function if this middle chunk went all the way to here, but it didn't. It stopped and it jumped up. Okay? So that's why I'm right here. I'm at 1. I'm in between the down 1 over 2. And I'm starting there, filling it in, and I'm going forever. All right, we got 2 more. Hopefully one of these is continuous because this had a jump. So this is also not continuous. All right, next one. We got x minus 2. So that is going to be a y-intercept of -2. And it is a filled-in circle, and it's going to be greater than 0. So we're going to be filled in. We have a slope of 1. So I'm going to go up 1 over 1, up 1 over 1. And I'm going to continue that forever over this way. Notice how I did not graph this part right here. I just did, but because it said greater than or equal to 0, I should not have included that, so that's why I'm erasing it now. What about the next one? We got -x minus 2. So it has the same y-intercept. This one has a negative slope, so that means that it is going to be going down 1 over by 1. And we don't want to graph anything bigger than 0. We should only include the part that is less than 0. So this part would not be included. That's why I just erased it. But this part over here would be included as a part of it. And this is an example of an absolute value graph. Absolute value graphs look like a V. And absolute value graphs are essentially 2 different piecewise functions that have the same potential y-intercept, or at least vertex, and then one has a positive slope and the other one has a negative version of that same slope. So that is the definition of an absolute value. All right, number 4. We got f of x is equal to -4. That is a horizontal line. Horizontal line at -4. And it is going, oh, by the way, this is continuous. Sorry. Number 3 is continuous. It goes, number 4, horizontal line at -4. 1, 2, 3, 4. And it is starting at -3 and ending at +2. So we have a hollow circle, 1, 2, 3, hollow circle at -3. And then it's going all the way up until +2, filled in circle because it has the bracket around it. All right. And then we have an absolute value graph. That absolute value graph is going to be having a vertex at x -3. So the vertex here would be 3, 0. That is the vertex. So let's plot that point at 1, 2, 3, 0. There's my vertex. And then this graph is going to be going up by 1 and over by 1, like so. Like that. It is also going to be going the opposite direction, up by 1 and over by 1, like so. Okay, what part needs to be erased? Well, we should only include this graph from 2 to infinity. So if we go over to 2, that would happen here. So we should have a hollow circle there because it doesn't include the 2. And we don't want everything before the 2. So that's why it starts right there. Okay, that's going to do it for this one, everybody. Until next time, stay positive, my friends, and I will see you all later. Bye.